Welcome back, everyone, to Inclusive Design 24, brought to you in partnership with our Platinum supporters, Barrier Break and Intopia, and our Gold supporters, InfoAxia and TetraLogical. You can follow us on Mastodon. If you have any questions for the presenters, post them using the hashtag ID24 hashtag. And you can also use the YouTube chat. We'll gather questions for Q&A at the end of the session. A reminder that ID24 is a respectful community and that you can find our code of conduct on the Inclusive Design 24 website. Now I'm happy to be joined by my guest host, Ricky Hansman.
Thank you, Hans. It's a pleasure to be here again, and I'm delighted to introduce you all to Joe Lamyman, who is going to give us a presentation as an introduction to XR accessibility. Over to you, Joe.
Lovely, thank you both. And yeah, such an honor to be presenting at ID24, so thank you for having me. My name is Joe Lamyman, and I'm a Senior Accessibility Specialist at TetraLogical. And in this talk titled Introduction to XR Accessibility, I'm going to be going through a few different design and development considerations that you can use to try and make your XR experiences more accessible. So you might be wondering, what is XR? Maybe you're not familiar, or maybe you could do with a bit of a reminder. Well, it's an acronym for the term extended reality, which is all about the blending of virtual and physical spaces. And it's an umbrella term, so it covers two things mainly, which are augmented reality, which you might have heard referred to as AR, and virtual reality, VR. So what is augmented reality? Well, it's the adding of digital images and virtual objects to the physical spaces. And on screen are two examples. There's two pictures. The first on the left is somebody who's using Instagram. They're recording themselves with their phone's front-facing camera. And on their camera feed, Instagram's adding virtual crowns in this case, and different filters. So this is an example of sort of the entertainment uses of AR. And it's also been popularized with things like Snapchat and Pokemon Go, which got really big a few years ago now. On the right is a series of screenshots from Google Maps' live view functionality, in which somebody's recording their surroundings using their phone's camera. And on their camera feed, Google Maps is augmenting directions like continued this way, or it's using arrows to point down a street that you should turn down. So this is an example of some of the instructional uses of AR as well. Virtual reality, VR, there's two examples on screen again. On the left is a case where somebody's using it for a game and they're throwing a donut at a robot. This is from Alchemy Labs' Job Simulator VR game. And on the right is a training use case in which somebody's wearing one of the VR headsets and they're sat in front of a series of flight controls so that they can use this to get better at flight simulators and training simulators. So VR is about immersing people in the 3D environments, and typically it uses a form of tracking like head tracking or things like motion controls in order to allow people to interact with the environment. So now that we know of a few different use cases, we're going to start to take a look at how we can make it accessible. And one of the first things that you might reach for could be the Web Content Accessibility Guidelines, or WCAG. And it's something that I use quite a lot in my day-to-day role. Its focus is on making web content more accessible. And for this, there's 86 different success criteria that include, lots of different guidance around how you can do that. The document is separated into 4 different sections, and within those sections, the success criteria are split across 3 different levels. It's been updated recently, I think it was last year, to version 2.2, but it's been a standard now for over 20 years. And it is the document that is used most for legal compliance when it comes to accessibility around the world. Typically, legislation will require that you adhere to WCAG. It tends to be different versions depending on where you are. Maybe it might be a slightly older version, but in general, they require that you comply with the level AA standard. And to do that, you have to meet all the single A success criteria and then all the AA success criteria. The idea being that these sort of build upon each other and help you provide an accessible experience. So it's really, really helpful for a number of different reasons. The first is that it obviously helps to make web content more accessible to people with disabilities. And there's guidelines that focus on specific disabilities as well, which is great. It also helps us to ensure consistency across the web as well. So in focusing on the same guidelines and in us all using the same guidelines, it helps to make sure that we're consistent in our approach and the techniques that we use to make web content accessible. This is useful because people can expect similar experiences from websites, and you don't have to relearn the web each time you come across different websites. And yeah, as I mentioned, guidelines that relate to specific disabilities. On screen is a poster from the Home Office's Designing for Poster series, in which they take some of the WCAG guidelines and take the guidance out of it and sort of try and produce these sort of simple, easier to understand recommendations. On the posters, it's separated between do's and don'ts. And yeah, they break down some of the more complex success criteria and include sort of a single statement or sentence that helps to explain what you should be doing and shouldn't be doing. So these are great. They distill a lot of the really specific WCAG information and just provide easier to understand and easier to follow guidelines. So focusing on XR, there are a number of challenges with WCAG. It doesn't cover all types, degrees, and combinations of disability. And I think this is quite important when we talk about XR, because within XR, there are a lot of different interactions and types of interactions that people might not be familiar with because they differ quite a lot from typical web use or mobile use. So there's a lot more to think about. And yeah, WCAG doesn't cover a whole range of disabilities. It also doesn't cover different combinations and degrees of disability. Additionally, there's few cognition-related criteria, and those that are in WCAG tend to be in the AAA success criteria that people aren't focusing on as much because, like I said earlier, legislation requires you to focus mainly on single A and double A. So again, this is important given some of the challenges with XR that we'll come on to in just a minute. And another issue with this is that WCAG is really great for web content. And if you've considered usability and you're developing something in tandem with that consideration, but if you're just focusing on the success criteria and maybe you're not too sure about how usability should work in XR, then given that there are not too many success criteria that directly apply to XR, you can focus on the criteria and not on usability, meaning that you haven't got, at the end, such a usable experience. You might find that there's maybe a handful of these success criteria that are relevant to XR, and the rest don't really apply. It's because mapping to other mediums is quite difficult with WCAG. It's because, like I said, this has been a standard for about 20 years now, excuse me, and yeah, some of the guidelines refer to things like HTML, page titles, links to bypass blocks of content, which aren't really a thing in XR. So trying to make that mapping is really difficult. And if you're focused specifically on sticking to the guidelines, a lot of stuff isn't going to apply, and you're not really going to be making a usable experience in XR. What we do have instead is the XR Accessibility User Requirements, or XRAUR, if you're a fan of acronyms. And it's another document by the W3C that includes 19 accessibility-related user needs. These are typically presented as a sentence or two. They're not particularly long or in depth, but what they do is sort of neatly describe how somebody would expect to use XR or want to use XR. Each of the user needs are broken down into requirements, which is really handy. Typically, there tends to be at least 2 or 3 of these, and they just help to provide a bit more context to the user need and also provide requirements that you can follow to help make these needs a little bit more tangible and easier to consider when designing and developing for XR. Sometimes they're still a little bit tricky to understand just because they're fairly broad in scope, some of them, because they're trying to be applicable to all the different types and contexts of use that XR can be used for. But yeah, we'll walk through a few of these in a moment just to provide a bit more depth to them. And the really nice thing about using the XR AUR document as well is that the guidance, the user needs and requirements aren't specific to the web as well. So it's been written in a way that it doesn't focus on specific technologies or hardware. It's technology agnostic. So regardless as to whether you're developing a VR or AR application, and regardless of the hardware that you're developing for, the needs and requirements in this document should still be relevant to you. So at the start, it does state that this document is most explicitly not a collection of baseline requirements. So the key thing here is to make sure that whatever you do, even if you follow all of this document and you're implementing all of the requirements, is to make sure that you are testing whatever you make with people with different disabilities, people from your audience, just to make sure that their needs have been considered and met. Yeah, this document does include loads of great stuff, but it's not going to cover everything. So that's something important to mention up front. And at the start, the authors do set out some general challenges with XR. Typically, these relate to the controllers that are paired with things like VR headsets. And on screen is an image of somebody holding VR headset controllers in their hands. These are the controllers that come with the Oculus headsets, and they have grips which are being held. And on the back of the controllers being operated with the index fingers are triggers. There's also a button on the side of the controllers, and then on the front of them are joysticks and buttons to be operated with the thumbs. So they require quite a high level of dexterity just to be able to hold and reach all the buttons. But then alongside this, you have to remember where all the buttons are when you're instructed to press them in an experience. So there's sort of a high cognitive load required there as well to make that mapping, press the right button. And then finally, typically these controllers will be motion controllers, and they require quite a fine level of motor control in order to hold them out and target things in the experience that you're using, and to also sort of keep your hands still and stable to target things successfully. So there's a challenge there as well. In order to address this and to try and help accessible experiences in general, you can address this by supporting different input methods. So don't be reliant on motion-only controls that might come with a VR headset. Instead, make sure that you're supporting different inputs. This might be something like switch controls or an adaptive controller, but just make sure that people can use a method of input that works best for them. And specifically in doing this, make sure that you design for the different inputs as well. So don't include an instruction in your experience that says wave using the motion controls if somebody's going to be using an adaptive controller. And it sounds simple and straightforward, but yeah, it's just making sure that we consider how people are going to be using the experience and design for them appropriately. Additionally, it should be possible for people to use simultaneous input methods as well. So it might be that somebody's able to use one of the VR motion controls in their left hand, but with their right hand, they prefer to use something like an adaptive controller. This should be possible too, and we should make sure that we design for this. And then finally, the last of these considerations is that we allow for the switching of input methods without affecting the user's experience. So if you imagine something where you're having to hold your arms up for a long period of time to use the controllers or the experience, this could get tiring for anybody. So it's about making sure that people can switch inputs at any point in time to something that's a bit more comfortable or easier to use so they can continue to use the experience. What we don't want to do is have to require somebody to exit the application, reconnect controllers, and then jump back into the experience, change the settings, because it could be a barrier for people to use the experience. What we do want to do is make sure that people can just change quickly and seamlessly and continue using it. But as always, it does depend. These things are context dependent, and it depends on the context of use in which your application or experience is being used. So, for example, things like affordances and the way you identify important objects might be something that you want to make really clear, easy, and obvious if you're designing a education or training experience. We want to make sure that people understand clearly how they should be using things. But this might change slightly if we're developing something like a game or an entertainment experience in which the goal is for people to navigate around the environment and find things on their own. We might want to implement different difficulty levels to address this because we don't want to make an experience where we hide affordances and people can't find the objects they need. So implementing things like different difficulty levels might be appropriate. And thinking about how people use the experiences over time is important as well, because people might need a lot of help or guidance and information at the start when they're first using the experience. But over time, they might become more used to it and familiar with it and might need less information, at which point we should make sure that people can update any settings related to this or can change the way they use the experience so that the help and guidance isn't distracting, doesn't prevent them from using the experience. So just make sure that what you're designing is specific to the way that people are going to be using it, and that if there are any settings to change things like help, guidance, affordances, that people can change these at any time, and they're not locked into anything based on the way they first set up the experience. It's really just thinking about how people want to use it and how people will want to use it over time. So we're going to jump into some of the requirements now. First, we'll go through the requirements of people with seeing disabilities. And one of the user needs in the document, this is the first user need, states that a user of assistive technology wants to navigate, identify locations, objects, and interact within an immersive environment. So you can see it's quite broad in scope. It covers quite a lot, but at a low level, it nicely defines how somebody would want to use XR. And as I mentioned earlier, in the XR AUR document, these user needs are broken down into different requirements. And for this one, there's 5 different requirements, which I'll very quickly run through. The first is that navigation must be intuitive with easy to understand affordances. It must be possible to remap, rearrange, and resize controls. Important objects can be easily identified. Important objects can be filtered, and objects can be queried for more information. So they really nicely break down the user need, but also cover quite a bit of ground between them. So that first requirement, navigation must be intuitive with easy to understand affordances, is quite different from the second requirement in that it should be possible to remap, rearrange, and resize controls. They're tackling quite different topics, quite different areas. So yeah, they're really helpful for just providing a little bit more depth as to what that user need means, and they help to unpack that. So we'll continue drilling down the document. We'll look at one of these requirements in a bit more depth, that navigation requirement, which states that navigation must be clear and easy to use. This could apply to things like menus and user interfaces that we're familiar with from the web or mobile design, but it also applies in general to how people navigate around the experience and to make sure that they know what it is that they can interact with in order to use the experience. So off the back of this, we need to make sure that navigation, location, and object descriptions are provided. So how do we describe to somebody where they are and what they're about to navigate to? How do we describe their location and environment? What objects are around them and what do they need to know about these in order to use them? And then finally, how do we describe the objects themselves, any information that relates to them and how people can interact with them? So to help us think through this, there's an example on screen, which is an image taken from a VR experience in which somebody stood in front of an open fuse box and they're holding a multimeter. In this case, we need to think about those 3 different things. First, how do we explain to them where they currently are, which is, stood in front of this fuse box, and then we'd need to think about how we would provide information to them about where they'd need to go next. The second thing we'd need to think about is the information around them in the environment. So the idea that there's a fuse box in front of them, this is currently open, there's a series of fuses, some are switched on, some are switched off, and then there's a number of wires that are leaving the fuse box and presumably heading somewhere else in the environment. Finally, object descriptions. So we'd need to explain that we're holding a multimeter, and we'd need to think about any important information conveyed by this, such as whether anything appears on the multimeter's digital screen. We'd need to provide this information in a way that people can understand what it is they need to do with these objects and how they need to interact with the environment. So when doing this, there's a number of different ways we can approach it. And I think really a multimodal approach works best. So not relying on a single way to convey information, but using things like audio, haptic feedback if it's available, to make sure that we can provide information in a few different ways so that people have those different ways of finding important information in the experience. So this could be something like a sound effect if you're using stereo audio or maybe mono audio. Hopefully with something like stereo audio, you can provide a directional sound effect that allows people to understand where it's coming from. With mono audio, maybe just a sound effect that alerts people to whether something's changed or whether they need to complete an objective. And then if the controllers that they're using are supporting haptic feedback, we could provide sort of a brief rumble, or with something like a VR experience or AR experience, we can add visual signifiers as well. Just thinking about the different ways in which we can provide that information and just making sure that we're not relying on a single way of doing so. An experience that does this really well is Cosmonius High, which is a game developed by Alchemy Labs. It's a VR experience in which people can change the settings. There's a screenshot displayed on this slide, which is the player using their settings menu, which is their backpack, and it's currently in a state where it's showing the settings relating to vision accessibility, and there's a switch that you can turn on for vision assistance. And when this is active, players can receive information about content using a text-to-speech engine. When you hover over information or content in the game, this will be announced by the text-to-speech engine, and it will announce things like a description of the object or any important information about the object. So yeah, that works by hovering over it or pointing to it. And it will also announce important information, such as if you pick up a book, not only will it describe that it's a book, but it will also explain visual information such as the title of the book and any important stuff relating to that. The game also provides descriptions of the navigation environment as well. So it will explain where you currently are. And then if you're trying to move to a different location, it will give you a brief explanation as to where you're moving to so you can understand whether that's correct and whether that's somewhere that you want to go. And then finally, it has these environmental descriptions as well, which will explain what it is that's around you and the different objects that you can interact with. This is really useful for making sure that you can understand that you're in the right place and have an understanding of what you can interact with. So we're going to go back to the requirements, and another of the requirements that I mentioned for that first user need is to do with remapping. It must be possible to remap, rearrange, and resize controls. And this might be particularly useful for people with low vision. Maybe there's areas in which you can't see, so being able to move controls into a location that's comfortable for you to use and to rearrange them is going to be a lot more usable for people. As well, that requirement about resizing the controls is useful in case the default experience doesn't provide you with the ability to see what the controls say or what the icons are. So being able to make the controls a size that's more comfortable and easier to use is really important. And then also it must be possible to adjust the sensitivity. So making sure that controls can be easily used. This might also be useful for people who have reduced motion, or maybe pressing buttons or holding joysticks is uncomfortable, making sure that you can change the sensitivity so that you're not having to tap buttons, but can instead press a button once or flick the joystick rather than having to hold it down. It's just about making sure that the experience is more comfortable for people and that they have the choice to operate it in the way that works best for them. Just going to take a quick drink, just a second. So on screen is a screenshot taken from the Apple Vision Pro. And it's sort of like a VR experience, AR experience, in which somebody's viewing their living room, but overlaid on top of it is the Photos app. What's important about this, though, is that in the screenshot, there's sort of a handle that's visible at the bottom right of the Photos application. And this can be used to resize the application in order to make it bigger or smaller, whichever works best for the user. And it's a really nice way of managing the user need and the requirements for making content bigger or smaller. And in a previous ID24 talk by Jesse Anderson, which is called an illegally cited look at VR accessibility, Jesse explained that as somebody with low vision, he often leans into the screen when using VR experiences in order to get closer to the text to read it, because often these experiences don't provide larger text, or large text still isn't big enough to read. So being able to resize windows is a really great way of helping people to use these experiences. And in addition to this, it's not only resizing that it offers, you're also able to move the windows around. So in the Vision Pro, you could move the Photos application closer to you in order to be able to read it, which is a much better solution, I think, because for people who might have reduced motion, it might not be comfortable to lean in. You might not be able to lean in to better read the text. Being able to move that window closer to you is a lot better in that regard. So another one of the user needs we're going to look at is in regards to screen magnification. And it states that screen magnification users may need to be able to check the context of their view in immersive environments. So yeah, this specifically relates to magnification. And if you're not familiar with how magnification works or how zoom works, it might be that when you're using a VR experience, depending on the way it works, you might just zoom into a portion of the screen so that you're able to see it easier. And you can imagine, if you haven't used this before, that when zoomed in, there's now a lot of content that will be outside of your field view that was previously visible on the screen. In this case, as designers and developers, it's important that we understand how this functionality is going to work so that we can design and develop for it appropriately. It might be that the magnification is provided at an operating system level, in which it's a case of understanding how that works so that you can design for it. Or it might be something that you need to provide or have already implemented yourselves, in which case knowing where the user's looking so that you can provide them with useful information is going to be key here. So if you do know where they're currently magnified on, you can make sure that you provide important information to that viewport. So things like notifications, alerts or errors, these can all be presented in a way that the user can still see them. And it doesn't have to just be text information again. It could be things like visual identifiers or audio effects that just make people aware that important information's appeared outside of their magnified view. So yeah, it's about trying to think about how people will be using the experience, but also understanding that they might not necessarily be able to see everything that's currently visible on screen, and thinking about the different ways in which we can make people aware that information has become visible and yeah, just make sure they can still have access to that information. We're going to move on to some requirements for people with thinking disabilities. This user need on screen states that users with cognitive and learning disabilities may need to personalize the immersive experience in various ways. And it breaks down into a requirement which is about muting non-critical content. It states that it must be possible to mute non-critical information like animations, visual content, audio content, and non-critical messaging. So you can imagine when you're using something like a VR experience, the headset itself is already quite a bulky piece of tech, which might prevent people from using the experience. But then once you're inside the immersive environment, it might be something that you don't recognize, an environment you don't recognize. There might be characters or objects that you don't recognize as well. So this might be overwhelming. It could be anxiety inducing, and these things, if not important and not core to the experience, might be a barrier to you using it. So what we want to do is make sure that we design and develop experiences in a way that we can deliver a core experience, and then on top of it, layer other things like non-critical visual content or sound effects, environmental sound effects, but layer these on top in a way that they can be removed if they need to, so that people can access the core experience. And it's not a case of the requirements stating that we can't develop rich immersive worlds with beautiful sound effects and visual content and animations. It's just about making sure that people can personalize and tailor their experience to make sure that it works best for them, and at its core, to make sure that people can continue to use the experience. You can include all of these different things, but just make sure that they're included in a way that they can be removed or switched off or customized. So moving on to requirements for people with hearing disabilities. One of the user needs for this is that a deaf or hard of hearing person for whom a written language may not be their first language may prefer signing a video for text, objects, or item descriptions. And this breaks down into a requirement which is about signing videos, specifically requiring that signing videos are present, which is great so that people can have that choice to use a language that they prefer, or it might be their primary language. Alongside this, we need to make sure that signing videos are included at an appropriate size as well. So the requirements specifically state that they have to be included at a size that's a third that of the stream's original size. And this is really important for making sure that sign language interpreters are clearly visible. Any gestures or expressions can be perceived, and so that it's easy to understand the signs being used. We're going to move on to some group requirements now. These relate to a number of different disabilities, and the user need that I'm going to focus on for this section states that users of assistive technology may have sophisticated routing requirements for various inputs and outputs, and the need to manage same. This breaks down into a requirement which is all about second screen devices, and specifically the requirement is supposed to be used for real-time communications. And it states that for real-time communications, it must be possible to send important information to a second screen. A second screen might be something like a monitor or a sound card or assistive technology like Braille output. It's about making sure that people can send important information to these different devices and use it in a way that works best for themselves. For things like touch input, it specifically states that you must be able to use the touchscreen gestures that people might be familiar with. This is really about making sure that people can use the technology in a way that works best for them and that they're familiar with and have come to expect. So don't try and change this in any way or provide new or novel interactions. Just make sure that people can use the hardware and their assistive tech in the way that they're familiar with. And then finally, where appropriate, it should be possible for people to manage the content that they send to a second screen as well. So some people might be happy with everything being sent to their assistive tech or second screen, but for others, they might just want specifically messaging information sent so they can quickly perceive and understand it and then respond to this. So I'm not going to go through any more of the user needs and requirements because there's quite a few, but I would recommend that you have a scan through because there's so much interesting information in there and a lot of things that I don't think I would have considered beforehand. So if you do only have time to look at a few, I'd recommend that you take a look at 4.6 color changes, which is your user need with requirements about how you can customize colors to better understand affordances and different information that's being conveyed in the experience. It's quite different to anything that I've come across for web or mobile accessibility. And then the other one is 4.15 interaction speed, which sort of builds upon some of the requirements in WCAG, in which it allows people to extend times and timings, but it also should allow people to change the speed of interaction so that it's more comfortable for people to use. And it requires that we include things like clear start and stop mechanisms and provide help throughout the experience. So one of the other things I want to cover is about the BBC's barriers browser research. And it's a piece of research by the BBC that really nicely covers how there are barriers because of the way that XR hardware requires people to interact. So off the back of this research, the research team identified 14 common barriers, which they found from analysing people with disabilities using XR. And these barriers are grouped into motor barriers, cognitive barriers, and low vision barriers. And they've sort of come at the question a little bit differently. Instead of trying to understand how they can better design for people, they've taken existing XR experiences and hardware and tried to ask, who does this technology disable due to the way that it's being created and the way that it requires people to interact? On screen is a picture of a virtual library that was used as part of the research. In it, the environments has these sort of large cream-colored walls with big bookcases placed in front of them containing lots of different nooks with lots of different books. And there's virtual light flooding in through the room's ceiling. And at the back of the room is an open wall leading to a cobble path and garden area. And there's so many fantastic takeaways from this research. So if you do have the time, there's a talk by Jamie and Lyon delivered to the XR Access group, which covers so many interesting topics. I'd really recommend that you have a look at that if you do have time. But one of the key takeaways from me was about making sure that we don't design and develop with a reliance on physical spaces. In the talk, Jamie explained a situation in which somebody using a wheelchair had the VR headset on and were in this immersive environment, and they navigated forwards towards the bookcase and wanted to explore through the books and see which books were available to them. In doing this, they didn't want to have to move around the bookcase. They just expected that they'd be able to grab the bookcase and swipe through or manipulate the bookcase in a way that would allow them to easily find content. But this wasn't the case because the developers hadn't designed for it. They hadn't intended for it to be used this way. But it's really about understanding why, because there's nothing that prevents us as designers and developers from making it behave that way. Like, this is the virtual environment. We don't need to recreate the physical inaccessible experiences. Instead, we should understand how people want to use them and make sure that we design and develop these appropriately. So yeah, it's about prioritizing the aim of the experience and why XR is being used in this case. It's about making sure that we include people with different disabilities during the design and development process and make sure that we get a clear understanding as to how people will expect to use the experience or their needs for using the experience. And we make sure that we design and develop for these appropriately. It's also really important to make sure that we don't wait until the end to include accessibility. What we don't want to happen is to have designed and developed this experience, and then at the end we're doing some final user acceptance testing, and we find that we haven't included people's needs and that people with disabilities can't use the experience. Instead, what we want to do is shift left and make sure that we tackle this stuff as early as possible and that we include people with disabilities right from the start so that we can get a better understanding of people's needs and of our audience's needs, and that these are catered for in our experience. So there's a little bit of time left, so I'm going to explain another takeaway as well. Going back to the slide with the library, like I said, at the end of the room is this cobbled path, and Jamie explained that there were some people who would encounter the cobbled path, and because of their experiences with the physical environments, they know that cobbled paths are difficult to walk over or navigate over. And with this understanding, people would approach the virtual environment the same way. They would encounter a cobbled path that wasn't real or was only real in the virtual space and wouldn't want to navigate over it, despite it not having any difficulty or not being any different to navigate over than the wood floor in the environment. So again, it's about making sure that we understand how people perceive our experiences and will expect to use them so that we don't break these expectations or don't overwhelm people or make people anxious when using our experience. So I'm just going to leave you with some additional resources or areas that you can investigate based on those that I've discussed. The first is the Browsing with Assistive Technology series from TetraLogical. It's a series of different videos that quickly cover how people might use different assistive technologies, and it's really useful for if you're not familiar with different assistive tech and haven't seen how people would use these. So I'd recommend looking at those. Another is the XR Accessibility User Requirements document, which is primarily the focus of this talk, and also the BBC's barriers browser research that I've just been through. There's also the Inclusive Design Principles, which are a framework that allows you to understand people's needs and design and development requirements that you can use for anything that you're developing, whether it's XR or web. It's just a useful framework to relate back to and get an understanding of how people might want to use different experiences. And then finally, we've just launched a XR accessibility blog series on the TetraLogical blog as well. So if you keep posted on the website, you'll make sure that you'll see the different series that we're releasing. They go into a bit more detail about these different areas that I've discussed, and hopefully offer useful considerations that you can take into your XR experiences. So thank you very much. That's me. And if there's any questions or you'd like to keep the conversation going, more than happy to.
Thank you very much, Joe. That was great. Ricky, did we get any questions so far?
Not on the well, we've got a few comments from Patrick here about I don't know whether they count as questions as such. He makes a comment about not having to recreate the physical environment and its limitations. And he comments that there was a big need to buy an island in Second Life push. Not sure quite what he's getting at there in terms of anything you can comment on there.
Well, he's saying that there's always this push of recreating physical, realities in a virtual space when that's really not a limitation you have to follow. Because obviously the physical environment is limited, especially from a person with disabilities point of view. So why would you recreate that in a virtual space? I completely agree with that. Like the library example that Joe gave, right?
Yes.
It doesn't need to be like that. It could be something that works much better in a virtual environment.
Absolutely. Yeah, I think it's just one of those things where it's really easy to think about what we already have, those physical spaces that we're so familiar with. But just making sure that we consider different people's needs. So if people with disabilities had been included from the start, maybe the library would have worked differently. Maybe people could have manipulated the bookcases, or maybe there would have been an even easier way to search through the different books there. People could have used voice control or a search form. There's a number of different ways that could have been approached.
Kind of reminds me of a few years ago at ID24, we had a talk about, I think it was like about digital assistants, like AI assistants. And why it's not necessary to make them like completely human-like, and make them pretend that they're humans. Like, it's fine that they're just some kind of automated system that you're talking to, and make it appear that way, and that it's actually better in a lot of cases. And it's the same for these kind of XR environments. I had another question. You mentioned the second screen requirement for things like sending and getting messages. I'm wondering if there's any kind of standardization efforts on the way to take something like on iOS, for example, you have the assistive touch feature that lets you map a basic gesture to a much more complex, multi-finger tracking gesture.
Mhm.
I'm wondering if you could have that second device also be an input device for this virtual environment where, let's say, the app does expect you to wave. Maybe there could be like a standard set of actions that you can physically do, and there could be just something that you can map to a wave action, or you could program it to, do a grab action on something by just tapping a part of your phone, or like you said, single switch device. Has there been any kind of standardization on the way to maybe define what these gestures could be, or just the ability to map them to another device?
Yeah, I don't think I have seen any efforts in that space at the moment. Um, no, in fact, there's not really much standardization in terms of just outputting information to second screen devices, which I think is a bit of a shame. I have seen a few different frameworks that have been released recently that people can use to develop XR experiences that start to address some of the requirements that I've covered in this talk. But yeah, specifically second screen devices, there's not been too much. I am encouraged by recent developments in accessibility in this space because of the way that Apple's Vision Pro has approached accessibility. It brings in a lot of features that just weren't possible, or not weren't possible, but just weren't included in other VR headsets. So I'm really hopeful that with that now, that the Apple team will continue to develop that, and that other teams such as Meta will see how this has been done, and we'll start to get improvements quite rapidly in this space. But yeah, at the moment, there's not much in that regard.
Yeah, it's kind of like
I have a
how Apple
question.
opened up the touchscreen,
Mm.
in this way as well for everybody else.
Yeah.
Go ahead, Ricky.
I have a question about closed captions in virtual reality
Mm.
headsets. It seems to me that closed captions on a fixed screen is a very different kettle of fish to when you've got them in front of you on a headpiece where there's a lot of movement involved. Is that really practical? How is that being developed so that the motion of people's heads doesn't blur the captions?
Yeah, that's really interesting. There's been a lot of discussions recently about captions in the XR space, and there's a group called XR Access that held a forum about different approaches for developing captions that are really usable in XR. There are a few different approaches. There's the sort of head-locked captions, which I think it might be what you're referring to, and sort of keeping these in the user's vision and in line with their head at all times, which can be useful. But another approach that I've seen that works really well is just trying to, well, for context, it was, I believe, from one of the games that I showed, I think it was Cosmonius High, in which there are characters that speak to the player, and the team keep these captions visible but related to the character so you can see who it is that's speaking. But when you turn your head away from that character, the caption sort of remains on screen, but it will sort of be in a position that allows you to identify where the voices come from or where the sound has come from. And it will
Right,
also
right.
include a picture of the character, maybe their name and what it is that they've said. So it sort of uses a little bit of a blend of head tracking for when you turn away, but yeah, sort of tries to keep it in focus. I can't remember too much more detail about it, but I think the XR Access group have that captions forum, which I watched recently, which was great. So I'd recommend, if you're interested in that, having a watch of that as well.
Right. That also answers another question that I had about how much common research there's been conducted between companies that are in this line of work. As you know, I mean, on one hand, they're individual vendors of products they want to sell, but are they actually working together to work out some standards, quite apart from the W3C stuff?
Yeah, there definitely is quite a bit of standardization work in this space. There's a group that includes a lot of different companies that are developing XR experiences. I can't remember what it's called now, but they're working on standards for things like the metaverse, and XR experiences. Specifically for accessibility, I think the XR Access group are the main people doing the work in this space, and they've also
Right.
been working with teams like those at Meta, to try and develop standards and requirements for accessibility as well. So yeah, there's a lot of really interesting research coming out of XR Access, and they had a symposium earlier in the year which covered students' research as well as research from the industry, and there's a number of talks that are on YouTube relating to that. So that's also another fantastic resource for this sort of work.
Right. It seems to me there's also quite a big difference in the application of XR accessibility to, on the one hand, entertainment,
Mhm.
and on the other hand, education and training. The
Mhm.
education and training is, I wouldn't say it's necessarily more significant, but it must have different kind of parameters on how successful, how accessible it can be made in order to achieve its purpose.
Yes, yeah, absolutely. They really are so heavily dependent on the context of use. And like I said earlier in the talk, it's about making sure that we provide quite a lot of information to people and make sure that people can clearly understand how they have to use the experience. So you could do this with different types of help mechanisms. So you might have, your standard instructions, but then you might want to include recordings of how people can complete these interactions along with an audio description as to how this works. But you might also want to change how this works over time as well. So when people become more experienced with the application or the training, you might want to reduce this slightly, or explain different areas of the interaction. It's not really something that should be treated as sort of a static thing. Like once people have started to use it, their expectations might change and they might want to personalize how the experience works. So it's about making sure that they can do this at any time, in order to make the experience more useful for them.
Yeah, fascinating stuff.
Do you think there could be any role for like an AI assistant to kind of be the layer in between the user and the system in this case? I can
Yeah.
imagine a blind person being in VR and getting like information about what's around them, and then say like, okay, well, I would like to grab that or would like to walk to that, and then the AI is kind of like managing all of that 3D space navigation, and that way it wouldn't be such a difficult task for the developer necessarily, but kind of be
Yes.
this person in between.
Absolutely. Yeah. I do think there is going to be space for that, particularly because if you can think about an XR experience, such as maybe a VR game in which objects are moving or the player moves objects, at that point, once things have started to move, it's not so easy for developers to clearly convey what it is that's around the user, because things might be coming and going, things might be changing. So having a way to sort of query an AI interface to understand what is around you, what's changed, what's become visible, where did I put that key that I was holding 2 minutes ago that I can't find anymore?
Yeah.
Those sorts of
Tell
questions
it
would
how much
be,
detail you want, like what kind of things
yes,
you're interested in, what you want to be kept up to date on.
absolutely. Yeah, those bits of information that will be really, really difficult to provide as a developer, I think, because of how dynamic the experiences are. It'd be great to use AI for that. And I think that's somewhere that AI could really improve the usability of these experiences.
All right. Well, I think we just got to the end of the Q&A time that we have.
Yeah.
So thank you very much, Joe, again, for this great presentation.
Yeah, thank you, Joe.
Let's just wrap,
Fascinating stuff.
Thank you.
let's just wrap this up. If you like the session, feel free to hit the YouTube like button. And you can also subscribe to our Inclusive Design 24 channel on YouTube if you want to be kept in the loop of what we're doing. And finally, I want to thank our sponsors again, our supporters, which is Barrier Break, Utopia, InfoAxia, TetraLogical, Intuit, Adrian Roselli LLC, Assistive Labs, the Law Office of Laney Feingold, Skyscanner, and Vispero.